Okay, so I have got built now the a different system for choosing which of the different types of spawns to put in, and I did it on a weight system, so I can add spawn weights. The higher the weight, more often it will spawn. And the way I did this was, so I make this star bonus arrangement is the actual script that's attached that has the weight in it. Each one of those is on the parent object that has a different arrangement of stars, right? So, this music. So anyway, so this at the beginning is going to programmatically go through all the objects that I have and fill the array up of star bonus arrangements out of my prefabs folder using this resources.find all objects of type, which is cool. And then so when we actually, this needs to be refactored, but the actual method to do the selection, first you add up all the weights. So for each of those star bonus arrangements in that array, add the total weight, all of them, and then for each object calculate and set the weight percentage. So then I more or less, so if you think like if I have 3 different objects that could be spawned, each of them carries with their own arbitrary and unique, well not arbitrary, but their own unique weight. So object 1 has a weight of 4, object 2 has a weight of 4, object 3 has a weight of 2. Okay, so 4 plus 2 makes a total of 10 is the total weight. And then, which is what I figure out here, total spawn weight, adds up the weights of all the objects. Then I make this total percentage, do I even, yeah I do of course. Right. I'll explain why the total percentage comes into play. So, okay, so we have 3 objects. One has a weight of 4, the second one has a weight of 4, third one has a weight of 2. It's a total of 10. So now take the first object and take its weight, which is 4, and divide it by 10. What do you get? You get 0.4, right? 0.4. So you end up with kind of like a 40% chance of that being spawned, or at least as a 40% weight out of the total weight of everybody. Second one, 40%. Third one, 20%, right? 0.2, because 2 divided by 10, 0.2. So, and I did some testing, and I found that if I had a bunch of, okay, so I add up all the weights together, the percentages. So once we're down to 40%, 40%, 20%, that equals 1, right? 0.4 plus 0.4 plus 0.2 equals 1, exactly. And I tried it with a bunch of different arrangements with a bunch of different weights, and most of the time it equaled 1. Every once in a while it equaled 0.9999999 repeating, because it just, that floating point decimal is just off, just barely. So I can't use 1 because there's a infinitely small, but not infinite, just a hugely small chance that the random number generator will spit out the number 1, because floats are inclusive, and I can't set the top end of the random.range to be exclusive for a float. It will include the number 1. So there's a chance that it could pick, the RNG could pick the number 1, and the total percentages of all the different objects only add up to 0.999999 anyway, so I add them all up, so that when I go ask the random number generator, I can say go from 0 to more or less 1, but this is the super specific 1, the very precise 1. It might be 0.999999, whatever. Anyway, last max is my next variable that I use. So that is, I'm going to assign between 0 and this total percentage, more or less between 0 and 1. So if your weight, back to our 3 object example, if the weight of the first object is 0.4, then we're going to loop through all the objects and say, okay, first object, your weight in percentages is 0.4. Okay, so since you're the first object, I'm going to assign you the a minimum of 0.0 and a maximum of 0.4. Now the next object, how much do you weigh in percentage? Well, you have a 0.4 also. So you are going to go from the max of the last object, which was 0.4, add your own weight to it, and that's your range. So your range is going to be from 0.4 to 0.8. And then go on to the next object. Well, how much do you weigh? You weigh 0.2. So I'll add you to the max of the last object, which is 0.8. So that's your minimum is 0.8, and your maximum is 0.8 plus your total weight and percentage, which is 0.2. So you get 0.8. It's kind of like playing, or from 0.8 to 1.0. So it's kind of like playing with pool with 3 people, like cutthroat. So you get the smalls, I get the mids, you get the highs. Only it's much more precise and it's not even. It's based on weight. It's not based on, well, whatever you call it, like based on fractions, equal fraction parts, like it would be in cutthroat. Anyway, so okay, so now each of them gets assigned their weight percentage, more or less in a range. Set the weight percentage in a range, so you have a max and a min, right? And that's exactly what I've done. So spawn percentage equals the spawn weight divided by the total weight. So now you know how much you have in percentage. And then your minimum chance, this is the range, is the min and max. So the minimum is the last max. So for the first object, it's going to start at 0. For the second object, we'll move on. So the first object gets 0 because last max starts at 0. The max equals the last max plus, really this should be arrangement dot chance minimum. Because you're saying, like the way I said it out loud was that you take, right, you want to say like I'm from 0 to 0.4, the next guy is take the last max, which is 0.4, which is now my minimum, and take my minimum plus my total weight, and that's my maximum, and then save it so that the next object can set its min and max. So anyway, the max equals your own minimum plus your own spawn percentage, then set last max to equal the chance max. So that way you basically keep the data outside of the for each loop. And then total percentage, I don't know if I can do that all in the same. Anyway, it's working. I'll go through that because that makes me wonder. Total percentage, I feel like that needs to be calculated before we do all this. Yeah, not necessarily actually. No, it doesn't. That's why I put it there. Because it'll add up the total percentage. The reason that that's important at the very end, I see. So total percentage adds up as it goes through and iterates through each of the objects. Then it adds the total percentage, which then will equal, like I said, either 1 or 0.99999. Anyway, so then the selection is a float. That's the random numbers. And then we go back, we loop through everybody again and more or less say, does the selection fall within the we don't need any of that. Does the selection, is it greater than or equal to the minimum and less than the max? So more or less your max is exclusive, because like this would be a problem if it nailed that number perfectly, because then you would have both objects. You'd have the min of the last one, because the min of the first object and the max, the max of the first object and the minimum of the second object are identical. So one side has to be inclusive and this side has to be exclusive. So I say, does this random number generator, I could just make that almost easy. If RNG is greater than or equal to the minimum and less than the max, then give me that arrangement. So more or less, does the random number generator fall within the range of this object? If not, go to the next object. If not, go to the next object. And then I put more or less like a just in case just in case one doesn't get called, but that code should never run, but that's just in case. And then it sends back the object, and then it puts it in space, which is pretty cool, and it actually works, which is the point. And you can see off to the left, so we got a single, we got a pentagon, we got a single, we got a diamond, we got a single, we got a single, we got a single, diamond, row, row, single, single. So out of just that, what did we get? 1, 2, 3, 4, 5, 6, 7 singles out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Out of 15, 7 out of 15. So about half of them are singles. And does that make sense? Kind of, because the total spawn weight is 2, 3, 5, 13. Now 8's not exactly half 13, but that was a pretty small sample set. Chances are, if we let that run for an hour and then calculated how many singles had dropped, chances are it would be somewhere right around 61 or 62, 61.5% of them would probably be, because it's 8 out of 13 on my spawn weight. So if I double that, then chances are we're going to get lots more singles. So that's how I can do the actual game testing. See, now loads of them are coming up as singles. And again, chances are, now that the total is 2, 3, sorry, I'm looking right here at my spawn weight. I don't know if you can see that, but I can set these from within the game, obviously. So 2, 3, 5 plus 16 is 21. So chances are, well, almost guaranteed that if we let it run for a long time, so just doing, that's the math that I've done in the code, it's about 76% of them will be singles. And, well, and if I set the weight at 1 with this setup, then 0.5% of them are going to be pentagons. And you can see, so far, there have been no pentagons. We'll probably let that run for a while before a pentagon shows up. Because the pentagon is set to only, has a spawn weight of 1. The diamonds have a spawn weight of 2. And there's a couple pentagons actually showed up. So it's pretty neat. A little bit better system. And then I've also set it up so that I can set the timer for how often. So if you want it to go from 10 to 20 seconds to spawn, you know, or let's say 2 to somewhere between 2 and 5 seconds to spawn. So I can set that right in here. And most importantly, see, now it doesn't spawn them nearly as often. Most importantly, and the coolest part about this, is since I did it programmatically now instead of hard coding it like I did before, I literally had it hard coded where it was like the single, pick a number between 1 and 100. If it's between 0 and 70, specifically, those are the numbers I told the script. If it's between 0 and 70, put a single. If it's between 70 and 85, put the row. If it's between 85 and 100, put the diamond shape. But then it's like, okay, so if I add a new shape, or a new arrangement, I've been calling them, then I have to go through and be like, okay, so what? Let me figure out what the new percentages are. Okay, screw that. They just have a weight now. So if I create a new object, and this, we're just going to call this another arrangement, and this is like where the programmer's setting it up so that the game designer can do what the game designer does. So this another arrangement, let's so let's say you wanted to make a new arrangement that was like the shape of like a chair. I don't know. and that's fine. So you've got these 4 star bonuses here. You put them into another arrangement, parent, add the component, the star bonus arrangement, give it a spawn weight of 50, and now that's the only one that will probably spawn. Well, let's make it actually spawn every once in a while. Oh, and this needs to, I'm sorry, this, you can't just do that. Have to put it in the prefabs folder. So now we have this arrangement saved in prefabs. We can delete this one safely and save. And then the bonus spawner, let's set it back to every second. So now I just made a new arrangement from within the game and gave it a huge weight. So now, yeah, see, the singles are popping up and another arrangements pretty much exclusively. Oh, so many bonuses, me lord. So yeah, it's pretty neat. So now the game designer can go in without knowing any code. I just set that up and then say, like, you know, okay, make me some arrangements that look cool. And then we go on from there. Anyway, that's the end of that.